I'm Paul Sesto, and I'm Javelin's 3D printing education specialist. I have both a science and mechanical engineering background along with industry experience and experience with 3D CAD and 3D printers. And though I've never been a school teacher, in my earlier years I was in the sailing industry, managing, teaching, and developing sailing programs for kids and adults both on the water and in the classroom. And I just think back to that time, it would have been great to have 3D printing to be able to develop teaching aids to convey the ideas and concepts of sailboats and how they move and how to sail. I'm speaking on a daily basis with teachers, Canadian teachers, educators, professors, technical staff from elementary and high schools, and colleges, universities, and researchers, as well as staff at public libraries, which are also a hotbed of 3D printing. And over the last year and a half, I've been visiting elementary and high schools, including the elementary libraries, talking and learning what's happening in the classrooms with the teachers and the students. And also I've had a chance to talk with IT staff and health and safety managers. We're Javelin Technologies. We're headquartered out of Oakville, Ontario, and we've been around since 1997, and we're Canada's leading 3D technology solution partner for 3D printing and 3D CAD. And a lot of people in industry, as well as in the academic world, know us as the #1 solid reseller for education and commercial use. And so you also know we've been recently awarded a 2-year master agreement with OECM, the Ontario Education Collaborative Marketplace, a procurement organization that helps the Ontario public sector. And our agreement is for the supply on an as-need basis of 3D printers to Ontario's public education system, including elementary and secondary schools. And as an end user, you may not have heard of OECM, but every school board purchasing department is certainly familiar with OECM. And it's through our OECM offerings that we actually have 7 different 3D printers that we can recommend to elementary and high schools. Javelin is very strong in the education market, and with 3D technology, we have over 130 different Canadian schools and academic organizations as clients. And we also have over 4,000 industry 3D technology clients, so we can help our education clients actually with what's happening out in industry to be able to see where their students are going in the future. We have actually the 2 world leaders. We represent the 2 world leaders in 3D printing. Stratasys has been around for over 26 years and is one of the originators of the 3D printing industry. They held the original patent on FDM, fused deposition modeling, and it was a patent that expired about 6 or 7 years ago, that the consumer hobby market, that's really started the consumer hobby market in 3D printing. And Stratasys is well known actually in the higher end of 3D printing for their commercial grade 3D printers that's used in industry as well as academics, and they're very robust, reliable printers that are designed to essentially be working day in, day out. We also have our MakerBot printers. MakerBot's emerged as the leader in the consumer hobby sector for 3D printing, and we differentiate these 2 printers really based on the cost and the expectation of what the printers can do. And if you can relate to it, I usually say that it's a bit like the difference between the large enterprise printers or photocopiers in the school offices that are spitting out reams of paper every day for the whole school, and that little inkjet printer that you might have hooked up in your classroom or at the school. There's 2 different functions, 2 different price points and features. MakerBot as well is a well-known name, and it's kind of like everyone referring to Kleenex instead of tissue. But it's a little-known fact that although like many other of the about 350 different companies and printers that are in that consumer hobby market, it also started out as a small startup, but it's actually owned by Stratasys as its parent company. So you really do have we really do have the 2 world leaders in the market. As the slide says, in industry, it's all about time to market. And industry needs are driving 3D printing companies to produce better materials, faster processes, better dependability, more ease of use, more realistic colors. And even for somebody in industry, it's difficult to keep up with everything that's happening in the 3D printing. But at Javelin, we have 80 people, and all of our resources from Stratus's MakerBot giving us information of what's happening out there. And even so, my parents who are in their 80s and who I've educated on what I do with the 3D printing and sample parts, and they're telling me about stories on CBC and how the local Canadian Tire is now advertising 3D printers. But it's certainly a different market when we're talking about industry and education. So in education, what I like about dealing with the education market is that everyone's very willing to share their experiences, share their stories. So there's lots of information online about 3D printers in the classroom, lots of lessons, ideas, etc. We view 3D printing as a fantastic tool for manufacturers, for industrial design, and engineering, and the list goes on. But in education, we always talk about the 3D printer being the destination, and it's really about the student's journey. And it certainly is fascinating watching the printer at work first and printing customized keychains and downloading from the web and so on. But that gets stale and pretty mundane in a short time period. So when we talk about 3D printing in education, this is where I think at schools you want to have it more than just a tick box that your school has a 3D printer too. And just as a short story, last night I was speaking with one of my best friends who's a high school principal at a high school north of Toronto, and they have a commercial grade Stratus printer. And he was telling me how one of their auto shop students was doing a restoration job as a project with the class on a 1950s car, and he was generally proud of his student for their problem-solving abilities. They couldn't get some clips from a supplier for the installation of the headlight. They simply were not available anymore. So the student actually did what's called reverse engineering the headlight clips. So he produced the headlight clips in a design and 3D printed them in order to solve his problem of installing the headlights. And the student so problem solved. He designed the clips from pictures that he saw, and he essentially worked out an elegant solution that would have been very time consuming and complex if he had done it in a traditional manner. So in education, as I said, it's all about the journey. The 3D printed part is the destination, but what are the students learning to get there? So 3D printing, it's sparking their imagination. It's getting them interested in STEM as well as in STEAM with the addition of the arts there. And now I find that every school has, I do find that every school has different needs. They have different objectives, and this is one of the things that you, in looking at 3D printing, you have to sort of define for yourself. So what I'm presenting today is what I find is some of the common themes of our conversations with teachers in schools. And what I want to do is stimulate some thought into what may be your current plans for getting into 3D printing with your school to help make it successful. And what I have to say, to start off is that you're on the right track because so many schools now are successfully using 3D printing. And so, welcome to our world of 3D. But it's important to know what your goals are and why you're doing this, what you're looking to improve in your programs, where you think 3D printing can help. And the course always comes back to how will the students benefit from 3D printing, and it has to be beyond just introducing them to the technology. So let's train them to be better problem solvers. Let's help them develop more team working skills. Let's have them experiment and test their ideas. I'm going to talk first about the materials with 3D printers and just what types of materials are available, because it comes into play into other areas for your consideration. And 3D printers do use different materials, or I should say, sorry, different 3D printers use different materials, and there's really a difference in the quality of parts and purposes. And let's remember that there's over 300 different printers in the consumer hobby sector, so many of these companies are trying to develop specialty materials that set them out from the crowd. But the primary materials that we see in the education market that everyone is talking about is PLA and ABS. And PLA, it's an organic starch-based plastic, and ABS is the type of plastic that if you're familiar with Lego or Lego bricks, that's what they're made of. And ABS is a stronger material, but it also is coming at a higher price point, and there's more needs from the 3D printer in order to get quality parts. So you really want to be matching your materials to your purposes. So PLA is great for entry-level printing, but if you have, let's say, a first robotics team at a high school, then they're generally looking for ABS for the strength and the quality of finish. One of the other things to consider is this going to be, is your 3D printer going into an elementary school, let's say for grades 4 to 6, or is this for a 7-8, or is this for high schools? There are different needs and considerations for each level as to what you can do with the 3D printers and what printer is appropriate for that program. So one printer doesn't really fit all. We have different solutions for different printers. And for an elementary school, it's usually recommended that you have a smaller enclosed printer. And for the 7-8s in the high school, this could be either the PLA or an ABS printer. It really depends on the purpose, and even in the higher grades. So just to add on to that aspect of the elementary school, a lot of them go with the PLA printers because they are smaller, they're enclosed, so that there's a safety factor there of getting fingers into the moving parts. And there's a lower price point too for those PLA printers. There's also different needs when you consider with secondary schools, whether it's going to be elementary entry level, or for technical courses or the high skills majors. The ABS, an ABS printer is going to give you a higher quality, more resilient functional model. And with our Stratasys printers, you can count on holes lining up and being accurate so that the object that you're designing actually works, and provided, of course, that it's properly designed. And that's also important to note that, the printer is only going to be putting out what is initially designed. So a printer can't do better than what the design is or correct the design mistakes. And from that aspect, it's one of the facts that one of the reasons why Javelin has actually developed and now offers a one-day training course for designing and 3D printing. So we don't actually teach you in this course how to use the printer per se, but how to get the most out of the your 3D printer from the design aspect. So we've taken all the tips and tricks and our best practices from our tech staff and others, and we teach a hands-on course. And if you want to have a quality printer, you also have to want to have the quality design and look at the part orientation and so forth. Another consideration is just whether the students will be using this for after-school projects like robotics. At higher levels, there might be a greater demand on the quality of the materials and the printed parts. So what's good for the entry level in high schools may not be what the first robotics program may need, or for some of the other special projects. You may also want to look at where else 3D printing can be used. In the schools, we can tend to think of technology first, but there is art and animation and the social sciences. And one of the perhaps the first science lessons that can be done on with 3D printing is just a lesson on why boats float, about Archimedes' principle. Let's design some small boats. Let's learn something about geometry, density of fluid, mathematics, testing principles. Let's put the boats in the water and see which one will hold the most weight by floating them, and let's graph the results. One of the other considerations with 3D printing is just how much experience the teacher may have with either 3D printing or 3D CAD. So there are, and for a number of years, perhaps they're called the shakers and movers of the 3D printing in the school. They're leading the way, and they've been doing this for some years. But now it's getting into more of the schools, and here we want to be able to say, let's walk before we run. We want to start off with the basics with some simple software, design software, but also it would be a good idea to try to connect up with other teachers who are already finding success. And you can start off by printing what's available on the net, and make sure you just sort of move, from one stage to another. But you have to remember, what I've learned too in just over the year and a half is that the students also learn very quickly, and a lot of times it's a great project where the students are leading the class. I'm here in Aurora, and last year at our local library that has a 3D printer, they were teaching a lesson on 3D CAD, and it was actually a grade 8 student running the class with his father. So it's an area where you can actually let the students do a lot of exploring and leading on their own. Now, it seems like everyone wants to jump on the bandwagon to get into technology, but it's harder to a bit harder to plan out and ensure it's used successfully. And to be successful in schools, we really see it as two components. You need safe, reliable, robust 3D printers, but you also have to have a learning curriculum. How are you going to integrate this into the various classes? So it's one area where we can help. MakerBot has a great book on MakerBot in the classroom, and if anyone wants, I can easily send you it's a free PDF book. I can send you the link, and it will help you get you started. But you want to, as I said, there's a lot of information online. You want to connect up with others who are perhaps doing some 3D printing and really gather from sort of their first successes, as opposed to trying to recreate the wheel yourself. One of the aspects that, it's not really necessary for us to ask people, if they want to buy a printer, hey, we'll sell it to you. But one of the things I always ask is, do you have a plan for 3D CAD? What are you going to design in? Because you really do have to have a 3D model in order to bring that model into the printer. And you want to be able to do that beyond, to have your students doing the designs and the projects, as opposed to just doing printing off of the internet and models. So there's lots of free software out there that the elementary and high schools can use. There's SketchUp, Tinkercad is appropriate for all levels. And for high schools, we actually highly recommend SolidWorks, and we do sell SolidWorks, and I guess that's the reason. But you also have to understand that 2/3 of the Ontario colleges and 75% of Ontario universities are using SolidWorks. So it's also preparing the students for their future education, be it if they're going into science or engineering. One of the questions that I'm always asked is, where should we install 3D printers? You're making a plan to have it in your school. And we tend to find that in the lower grades, libraries are a very common place to have a 3D printer, because it's getting exposure and interest from other students. The librarian a lot of times is doubled up as an IT resource for the school. And it allows that it allows a focal point for that technology. In other schools, let's say in high schools, the 3D printer may go into tech shops. In general, a 3D printer should have some good ventilation and air circulation around it. It is a unit that has a computer in it, that has fan, and so just needs that insulation. One of the other tips, and if you're going to get a 3D printer into a classroom, is that the filament printers that we have with MakerBot and Stratasys, the filament is actually affected by UV light and humidity. So when you're not using the printer for an extended time, let's say during the summer or the school break, the filament should actually be stored away in a sealed bag. and the printer should actually not be in sort of sitting in direct sunlight if it was, let's say, placed by a window. Because the filament can absorb the moisture and it then can cause sputtering and clogged extruders. And it's generally the extruders that give people the most problems, and that really defines the difference between many of these types of 3D printers, and it's one of the reasons why Stratasys and MakerBot actually have very reliable printers because of their technology with those extruders. Another consideration in if you're looking at 3D printers is about warranties and technical support. Some printers only have a very limited warranty, and it may even be different for home or commercial use or for school use. The standard warranty on our MakerBots is 6 months and with 60 days of email support, but that's why we've made a conscious decision with our OECM contract to only sell MakerBots with a minimum of their 1-year Maker Care warranty, because we want to just ensure that everyone has the best coverage. So one of the things you want, for some schools that are just getting into this technology, you want to be able to protect your investment and be able to get the help when you need it. So whether you're, getting a printer from us or from anyone else, you want to know, what type of support is there. Is it email? Is it phone? Is it chat? Is there an online community to draw upon? And are there others there to help you? So those are some especially important questions to get answered if you're a new user to 3D printing. One of the other considerations, of course, is budget and sort of getting a best match for that. And it really is like any other technology or machine. You do get what you pay for. We define the commercial hobby market as printers from $500 to about $6,000, and then the commercial market from $6,000 up. And for that $500, you can actually get a kit that you can build your own printer, and that may be appropriate for the schools that are looking for a challenge, and they have students that are doing let's say science projects or electronics, or they're into robotics and they're going to be building it. But for those who really want to concentrate on the lessons and the curriculum, then you really want to leave the tinkering and hacking of the printers to the others at that stage. And with every printer, we really look at it, each one has its own purpose. Each printer has a different build size and different materials that it might be, it can use. And that's why at Javelin, we really want to match the right printer to your needs and your goals and budget. And that's why we actually have a range of 3D printers. So as I mentioned at the start, we have 7 different printers, 3D printers that we can recommend. And really you want to get the most out of your budget. So at some point it seems like everyone wants to build bigger. So if your budget can afford it, what I always recommend is trying to get the most or the largest printer you can, because it just seems like after a year everyone's saying, okay, I'm ready for the next one, or I have limitations. You can build parts on any printer or on most printers where you can glue them together, so you split up the design. But getting a larger printer at the start is always better from that aspect. We're actually just sort of nearing the end here, so just want to tell you that we're here to help, and want to thank you very much for taking the time for your schedules. And just so you know, we do have promotional pricing on our MakerBot bundles running until June 15th. That has extra extruders, our SolidWorks education software, as well as free 3D print training. Sorry.